Hello friends, this is Manas Ranjan Panigrahi from SEMCA, Commonwealth of Learning. I welcome you all to this last live session of MOOC on Introduction to Statistical Analysis. I believe you all enjoying this course and almost all big activities and through all the resources you have been and completing towards the course. So with these words, I would like to request you few things which is very necessary you need to complete to earn your certificate, and that is very important aspect. So I would like to request first of all, those who are not yet completed your pre-course survey, which is again available in announcement section, please go through that and fill the pre-survey course. That is one of the important activity, and try to complete all the quizzes which has been released every week, and these quizzes will be going to be closed on 7th of June. So those who are not yet completed, please complete your quizzes as soon as possible and earn your score as per the certification criteria. You will get your certificate. Those who are not yet completed your watching videos, downloading PPTs, and downloading e-texts, please do that. That is also criteria for the earning your certificate. At the same time, I would also request kindly visit to your assignment section and get downloaded your assignment format, read your assignment, prepare your assignment, and submit the same as soon as possible without making any delay to face the last moment of failure to upload your assignment. The last date is 10th June. And by this time, you need to complete your assignment as well as your quizzes by 7th June need to be completed. As per the certification criteria, you know that 50% score in all components for participation certificate and 60% in all for the completion certificate. I hope you understand my request, and this will give you your certificate. No doubt you are learning, you are participating adequately, effectively. Also, kindly note, if you are not yet respond to any forum, please go to the forum, respond to the forum, as well as create also forums according to your understanding, because the creating forum or responding to forum, this is also one of the criteria to get your certificate. With these words, again, I welcome you all to this last live session for the MOOC Introduction to Statistical Analysis. And now I am happy to invite Dr. Manoj Das and all our mentors, those who are presented today here, and they will interact with you directly to discuss various issues. Where whatever you have any doubt, you can feel free to ask your questions, but I would like to request kindly raise your virtual hand, then I will allow you unmuting your mic, or I am telling your name so that you can unmute your mic immediately and ask your questions. Before that, now I would like to request Dr. Manoj Das, your lead instructor, to reflect in this last live session on the MOOC. So over to Dr. Das, please.
Thank you, Dr. Manas. First of all, a warm welcome to all the learners to the last live session of this MOOC. So I hope you got all the points that Dr. Manas has highlighted. Kindly look into those points so that it would be very easy for you to add a certificate of participation, and on the basis of a evaluation to be completed, that is your assignment, subsequently you will also get the certificate of completion. Both are very important for you. So you have spared 1 month. So little bit work is there at the end of the course. With this, you will be able to earn 2 different certificates simultaneously. So wish you all the best. So without sparing much time, now let us look into the solutions of reflection questions. As per your request, we will be taking up last few questions of reflection question 2. That is question number 3, 4, and 5. Subsequently, we will see the reflection question 3 and reflection question 5. So this time we will go a little bit with a speed so that you will be able to catch the points. Now, yes, look into the reflection question. Sorry. Question number 3. Yes. Yes, this is our question number 3. So the question is very clear. We are trying to find out the level of significance on the basis of the standard error of mean. Your mean and standard deviation of a group of 120 students are given. Just analyze the question without considering the whole aspects. If you analyze, it will be easy for you to further proceed. Your total number of the student is 120. Mean is found to be 48, and the standard deviation is 12.6. Now we have 3 bits. Let us consider each bit one by one. So this is what is our question. If you look into the question, if you analyze the question, this is what the information we will get. I hope this is clear to you. Immediately find out standard error of mean, which is already known to you. That is standard deviation by root over of n, you will get 1.5. After finding out the standard error of mean, now make an inference, make a prediction. What will be your population mean and what will be your sample mean? So sample mean will be between population mean plus minus 3 ACM. This is the standard area that is covered under the normal probability curve. Now the first thing is that find the 99% confidence level, that is 0.01 level. That is 0.01 level interval for the population mean and interpret the result. See, this is what is the range m plus minus 2.58 ACM. 2.58 ACM means 2.58 is the critical ratio at 0.01 level for two-tailed test. It is a two-tailed test, so we are taking critical ratio 2.58. So you will get the answer this. If you solve this one, you will get the range will be 45.03 to 50.97. So this is what is the result of the question. Now how to interpret it? Much important is how to interpret the result. This is what is required in the assignment. Look into this aspect. We are 99% confident that population mean will be between these two ranges. Now, our mean must be a value between 45.03 to 50.9. Second, our sample mean 48 will not miss the population mean by more than 2.97. Means the 45.032 minus, if you get 50.9, the difference is 2.97. So this is what is the margin within which we are expecting that our population mean must be a part of. So this is true for 99% of cases out of 100. So we are taking chance of only 1%. Alternatively, we can say that only 1% cases the mean may go outside this range. Means that is, we will miss the population mean by more than 2.97. So this is what is the whole interpretation of the 99% confidence level. I hope you have solved it and you must have got this answer. Now coming to the second bit, find the 95% confidence interval. In the first bit, we had 99% confidence interval. So we have taken the critical value 2.58. In the second bit, it is asked for 95% confidence interval. So the critical value will only be changed. Sorry, the critical value will only be changed. That is, here at 0.05 level, the critical value is 1.96. So in place of 2.58, you take 1.96 and solve the question. So this is what is the answer. Rest all other things are remains the same. So the range will be changed. It is 45.75 to 50.25. So we are 95% confident that our sample mean will be within this range, or the sample mean will not meet the population mean by more than 45.75 to 50.25. So this is what is the range at 95% confidence level. So interpretation is this, exactly in the same way we have done the interpretation for 99% confident level, 0.01 level. You can make the interpretation for 0.05 level of significance. I hope this aspect is quite clear to you. I am not going to take much time on it. Now, see the third bit. The third bit is little bit different from the first bit and second bit. Find the acceptable and allowable sampling error at 0.05 level of significance and 0.01 level of significance. The question is remains the same, but it is slightly modified. It is slightly tilted. You are required to give the limit or the range for 0.5 level and 0.1 level, which we have already done in first bit and second bit. See, acceptable and allowable at 0.05 level of significance. If it is 0.5 level, so our critical value is 1.96. So we are getting this value 2.25. Similarly, for 0.01, you find out for 0.01, we will get the range is this one, 2.97. Because the critical value is only changed. Here we have used the critical value 1.96. In the 0.01 level, we have used the critical value 0.01. Accordingly, you will get the value. Now, see what is the.
Hello, sir.
Yes.
Hello. Hello, sir.
Yes.
Sir, I have already submitted the project which you have given.
Kindly note your questions. We will take up all the questions at the end. Please. Kindly note down your questions and raise your hand. Dr. Manos will call one by one. We will take all the issues and all the queries. This is my sincere request to all the learners, please. Now, this is what is the acceptable range for 1.96, that is 0.01 level and 0.05 level. Now coming to the last question, fourth question. See, that question is already with you. Look into the question. So this is what is the whole question. If you analyze the question, we will get this is the value. Our number of sample is 75, mean is 52, standard deviation is 10. Immediately find out standard error of mean. The procedure remains the same. Standard error of mean. So all the data are given. Easily you can find out standard error of mean, that is 1.15. Now, what is the first bit? Look into the first bit. What is the probability that the sample mean will not miss the population mean by more than 3 kg? Question is bit tilted. It is not much difficult. Very simple question. What is the probability that the sample mean will not miss the population mean by more than 3? So the question is this. Find the Z value, D by ACM. D is the difference between the mean. What is given? It will not miss the population mean by more than 3 kg. Means the difference is 3. In place of D, difference, put the 3 and proceed. You will get Z value is 2.61. Now refer to the Z table. It is table A, which is already given in the resource page. If you refer to the Z table, 2.61. It is 2.61, not 16. Kindly correct it. 2.61. 2.61 sigma include 99.10% of cases. This is very important. What is the probability that the sample mean will not miss the population mean by more than 3 kg? So we are getting the area 99.10. So here the probability is 0.9910. So what is the probability? The probability is 0.9910 that the sample mean will not miss the population mean by more than 3 kg. Now, what is the probability that the sample mean will miss the population mean by more than 3 kg, 3.5 kg? 3. In that case will not miss, it was given, but it is given will miss the population mean by more than 3.5 kg. The only difference is this. Now see how to proceed. Exactly same way. Let us find out the Z value. Z value is 3.04 because D is 3.5. Now refer to the table. 3.04 sigma include 99.67%. 99.67%. What is given? Will miss the population mean. The question is not will not miss the population mean. The question is will miss the population mean. Means it is beyond 99.76%. So what we will do? So the probability is 0.9976% that the population mean, the sample mean will not miss the population mean by 3.5. Will not miss, but we have to find out will miss the, so 100 minus 99.76. So the range will be outside 99.76. So total area is 100%. 100 minus 99.76. You will get 0.24% of cases would lie outside the range. So our probability is 0.24%. Alternatively, in what way we can represent it? In what way we can analyze and interpret it? We can interpret in this way that 0.024 probability is 0.024 that the sample mean will miss the population mean by 3.5 or more. This is what is the result. This is what is the analysis and interpretation we have made. So this is the question. You have to see the question what is asked. Accordingly, you have to take whether to subtract it out of 100 or you will take that exactly. Now coming to the question number 5. The mean wage and standard deviation of a group of 10 workers were found to be 350 rupees and 12.8 respectively. Mean is 350 and standard deviation is 12.5. Let us take each bit one by one. If you will solve one bit, second bit you will solve automatically because only the level of significance is different. See, these are the given data. The given data you will get if you analyze the question. Analysis of the question will give you this result. Now find out the standard error of mean. You will get the standard error of mean is 4.05. Our standard error of mean is 4.05. Now find the limit of 0.95 confidence level. Okay. See, what is the degree of freedom? n-1. Total number of the days, that is 10 minus 1, 9. Degree of freedom is 9. Now in this case, we have to refer to T distribution table. The T distribution table is given, that is the second table, table B. There are two tables given in at the resource page. One is table A, another is table B. Table A is for Z value, table B is for T value. So referring to the table B, you will get that where degree of freedom is 9. Under degree of freedom 9, at 0.05 level of significance is 2.26. Means this is the critical value. This is the table value. This is what is the table value, 2.26. Now we will compare our calculated value with the table value. So what is the 95% confidence interval? Mean plus minus 2.26 ACM. Find out 2.26 into our ACM is 4.05. This 2.26 we are getting from the table. We are getting from the table, and 4.05 is our standard error of mean. Standard error of mean. Multiply these two, you will get the answer 9.15. So the range is 350 plus minus 9.15. That is 350 minus 9.15, 350 plus 9.15. So this is where you will get that what is exactly the range, what exactly the range is. So our range is 340 plus 8.5 to 359 plus 1.5. This is what is the range you will get. So the limit, 95% confidence interval, the limit will be, this is the limit or this is the range, you will be able to find out. So what is the probability? So probability is 0.95 that population mean would lie in between the interval 340.85 to 355.15. I hope you have got this answer and you must have analyzed and interpret in your reference questions, reflection questions as well. Now, this bit is exactly same as that of the previous bit. Let us not take much time because only the critical level is different. Here, we have done the question with what? 0.95 confidence interval, 95% level. Now you are doing 99% level, means 0.01 level of significance. Only the critical value will be different. Exactly the same. Fine. Find out the degree of freedom. Degree of freedom is 9. T value at here we have to take under 99.01 level. That is 0.01 level, where you will get the answer 3.25. So find out the range 3.25 plus into ACM. 13.16. See, this is what is the range you will get. I hope you must have got this value also. You compare your answer what you have got with the answer that we have been sharing with you. In case of any somewhere something wrong, you may correct it and rectify it accordingly. Now, in what way you will interpret it? This is the way of interpretation. This is the way of interpretation. The limit of 99% confidence interval include 336.84 to 363.16. So what is the probability? The probability is 0.99. So we are 99% confident that the limit will be within this range. How much risk we are taking? We are taking only a risk of 1%. So this is all about your question number. What is that? This is the reference question 2. I hope this aspect is clear to you. In case of any doubt from question number, from our what it is, reflection question 2. In case of any doubt, feel free to note down the questions. We'll take up all the questions during the question answer session. Now let us enter into the reflection question 3, which is very important. Okay. Testing of a hypothesis. Reflection question 3. Look at the reflection question 3. One or two things I would like to tell you. In reflection question 3, that this is the first question. Okay. Yes, this is the first question. All the reflection question 3 are from the module 3. The module 3 concept was testing the hypothesis. Testing the hypothesis. See, in the question module 2, whatever the questions we have solved, we have not framed the null hypothesis and we don't have any alternate hypothesis. Directly taking standard error of mean. Taking standard error of mean, we tried to solve the question. Means the level of significance was assessed and we have interpreted. We made an inference on the basis of standard error of mean. Now, in the question type module 3, we have dealt with testing hypothesis. Here we have set the hypothesis and we are going to set the null hypothesis. We are going to set the alternate hypothesis, and based on our result, we will go to see whether the null hypothesis is accepted or rejected. So basically, this is what is the aspect that are there. So the steps are almost same. Only one step is different that we will discuss through this example. See, look into your example. In a city COVID hospital, average heartbeat of the people, that is the patients from group 40 to 50 are given, with standard deviation is also given 12 beat per minute. A group of 50 patients were examined and average heartbeat was found to be 75 beats. Test whether the difference is significant at 0-1 level or not. Test. So here we need to see how we will proceed. There is a bit different between the problems what we have solved in the second reflection questions and the third reflection questions. See, what is the given data? These are all given data. I have not created anything. From the question only you will get all these things. See, mean of the population is how much? Standard deviation is how? 12. N is equal to 50. Sample mean is equal to 75. These are the given data. What we have to do? What we have to do? So we have to test whether the difference is significant at 0.01 level or not. This is what is the question we have to do. The whole question is this. Now, find out the standard error of mean. Already known to you, sigma by root over of n. So if you find, you will get the standard error of mean is 1.69. What is the Z value? Find out the Z value, already known to you. That is B by ACM. What is B? Mean of the population minus mean of the sample. Difference between the two mean. Difference between the two mean. 75 was the population mean, 72 was the sample mean. So get the mean, you will get 1.77. So 1.77 is the Z value that we call calculated value. We call it a calculated value. Now coming to Z 0.1. What is this? This is critical value. This is critical value. We will get it from the table, or this is the standard value. So if you are associated with doing the simple research and impact studies, you must be using it. Critical value is 2.58. 0.01 level critical value is 2.58. If it would have 0.05, then the critical value is 1.96. Anyway, now see, our calculated value is less than the critical value. If the calculated value is less than the critical value, the difference between the sample mean and the population mean is not significant. Note it. This is the interpretation. The difference between the two mean is not significant. So we are 99% confident that the difference is not significant. So only we may wrong in 1%. Means we are taking 1% risk in stating this, in giving this statement that the difference is not significant. Means 99% confident we have, the researcher or the investigator have the confidence of 99%. So what is the probability? The probability is 0.99. The probability is 0.99. And the probability of the chance of error is 0.01. See, what is the null hypothesis? This is the null hypothesis. If you would have said the null hypothesis states that the population mean is equal to the sample mean. There is no significant difference between the sample mean and the population mean. Mathematically, we can represent it like this. Mu is equal to mu1. Mu is the population mean. Mu1 is the sample mean. Now, what is the alternate hypothesis? Alternate hypothesis said that they are not equal. Can you tell me, is it a two-tailed test or one-tailed test? Is it a two-tailed test or one-tailed test? Of course, it is a two-tailed test. Because here it is given.
It is a two-tailed test.
One-tailed test. How it is a one-tailed test? It is not. See, look at the alternate hypothesis. Mu is not equal to mu1. Mu is not equal to mu1. The chance is that mu may be greater than mu1. Okay? Mu may be less than mu1. Means the population mean may be greater than the sample mean. The population mean may be smaller than the sample mean. The alternate hypothesis is not clearly given whether the population mean is greater than sample mean or the smaller than sample mean. So in this case, can you tell me whether the test is a one-tailed test or two-tailed test? It is a two-tailed test.
Two-tailed test.
Yes, it is a two-tailed test.
Two-tailed test.
Two-tailed test. The reason is I am giving you, in case of one-tailed test, the alternative hypothesis will clearly say that the sample mean will be greater than the population mean, or the sample mean is less than the population mean. If it is that is what we call a left-tailed test or a right-tailed test. Untailed test means either it is a left-tailed test or it is a right-tailed test. What do you mean by a left-tailed test?
Okay.
If it is less than the population mean, if it is less than the population mean, it will go left side of the normal probability curve, left to the mean. So it is a left-tailed test. If it is more than, it will be the right. The position will be right side of the mean. If the position is right side of the mean, the value is in the positive. So it is a right-tailed test. So very important. There was a question in the quiz question was given whether it was with directional hypothesis or non-directional hypothesis. It depends upon what? It depends upon the alternate hypothesis. Can you tell me whether the alternate hypothesis is directional or non-directional in this case?
Non-directional.
Non-directional. Non-directional.
Yes, exactly. The alternate hypothesis, the way it is given, it is a non-directional hypothesis. It has not given any direction, whether we will go more than the mean or we will go less than the mean. So there is a probability that the mean may be greater than the population mean, may be greater than the sample mean, may be smaller than the sample mean. So in this case, it is a two-tailed test. Now, considering two-tailed test. Look at this one. Sorry. Now, consider the case of question number 2. I hope the question is already with you. You must have a copy of the reflection question in your hand. So go through it. You will get, it will be little bit easy for you, so that with a faster rate we can move, so that we can complete module 3 and module 4. 3 and 4. See, this is the question. I hope I need not read the question. I will analyze the question in the next slide. Mental ability test of 150 tribal youth is given for 20 years age in a state. In your state, the mean and standard deviation is given 105 and 12. Now we'll solve the question one by one. How much sample is taken? 30 samples are drawn out of 150. 30 samples are drawn out of 150. How to analyze it? I hope this much is very clear to you. Again, you are repeating the same thing. Okay? Given data are, we have noted the given data. Let us first estimate the ACM, standard error of mean, that is 2.19. Okay. Consider the big one. What is the probability that the sample mean will be 100 or less? The sample mean will be 100 or less. Let us first find out the Z value. I'm sorry, this is a negative sign. Sorry, minus sign. Z is equal to sample mean minus population mean by ACM. It is not equal, it is minus. Please read it as minus. The cursor is given here. Okay. So 100 minus 105 by 2.1. Our Z value is coming minus 2.28. Minus 2.28 means it is what? Left side of the normal probability, the mean. So refer to the table A. Minus 2.28 means 2.28. In the table, you will not get minus 2.28 or plus 2.28. You will get 2.28. If you refer to the table, you will get that there are 0.0113% of cases. This value you will get from the table. 0.0113 directly. In the column, you take 2.2. In the extreme left column, you take 2.2. And in the horizontal row, you take 0.08. 0.08. Where the two lines will cross each other, you will get 0.0113. Hence, the probability is 0.0113. So, what was the question? What is the probability that the sample mean will be 100 or less? The probability is 0.0113 that the sample mean will be 100 or less. Coming to the second bit. What is the probability that the sample mean will be 105 or more? The question is slightly deviated. Just like in the standard 10 and 12, we are making a little bit changes in the question. Exactly in the question, it slightly changed. 105 or more. Find out sample mean minus how much is you are getting. So here you will get the value is this. Okay. The moment you will get that value, we find that there are 0.5 cases. Hence, the probability of getting a sample mean of 105 or more is 0.5. So here the probability we are getting 0.5. Now coming to next one. What is the probability of having a mean that would differ from population mean by 4 points? So population mean minus sample mean is 5 points. That is given in the question. if the difference is 5, consider that if the difference is 5, what would be the probability? If the difference is 5, what would be the probability? Exactly in the same way, 5 more or less. If it is given 5 point, there may be 5 more than that, it may be 5 less than that. So what is the difference? Difference is 5. So 5 by 2.19, we will get 2.28. Now take this 2.28, refer to table A. Take this 2.28, refer to table A. What you will get? You will get 0.0113. So here, what we are doing, you just mark it. What would be the probability of having the mean that would differ the population mean by 4.5? Means if you go to the left side, 0.0133 you will get, beyond minus 2.28, and after 2.28 you get 0.0113. So beyond that negative z value and after that negative z value, both the value you just add it, you will get 0.226. So in what way you will interpret? We can interpret that the probability of having a mean by 5 point is 0.0226. This is the probability. Similarly, find the deviation of sample mean from the population mean at probability less than equal to 0.01, means 99%. What is the deviation? What is the deviation of sample mean from the population mean at 0.01 level? Exactly in the same way, you see. At 0.01 level, what is the critical value? 2.58. The optimum deviation find out, 2.58 ACM. You will get 5.6. If you get 5.6, therefore probability is less than equal to 0.01. The deviation will be 5.56 or less. It will not be more than 5.56. The deviation of the sample mean and the population mean will from the population mean will not be 5.56. The optimum deviation will be 5.56. Come to the question number 3. Now take your time and just 10 seconds you analyze the question. Just you take your 10 seconds and analyze the question. If you have a piece of question with you, it would be easy, or else from the screen you can analyze. Okay, let's see. This is given in the question. I am not doing something different. Population mean is given in the question. Standard deviation is given in the question. Number of sample is 100, given in the question. Sample mean is 115. This is also given in the question. What we have to do? What would be our null hypothesis? So this is the null hypothesis. This is the null hypothesis. What is null hypothesis? There is no significant difference between the sample mean and population mean. What is the sample mean? 115. What is the population mean? 110. There is no significant difference. Yes, there is a difference. We understand there is a difference of 5 points, 110 and 115, but the difference is significant or not. So null hypothesis states that the sample mean is equal to the population mean. Means the sample mean is equal to population means there is no significant difference between the two. What is the alternate hypothesis? They are not equal. The sample mean is not equal to population mean. Now come find out the standard error of mean. Our standard error of mean. Already given value, I have just calculated it. See. 0.05 level, critical value is 1.96. So this is our calculated value, 4.166. This is the calculated value. So what do we find? The calculated value is much more greater than the table value, the critical value. The calculated value is greater than the critical value. Now you tell, if the calculated value is greater than the critical value, what we will say? What we will say? We'll accept the null hypothesis or reject the null hypothesis?
We reject.
Rejecting null hypothesis.
We will reject the null hypothesis. So null hypothesis is rejected. If we reject the null hypothesis means, what does null hypothesis say? Null hypothesis said there is no significant difference. We are rejecting the null hypothesis. Means this shows that there is a significant difference. There is a significant difference between the two. Now let us see, this is our result. See, on the basis of calculation, whatever we have done in front of your screen, this is the result. How to analyze them. This is what is the interpretation. This is what is the interpretation. The interpretation is very important on the part of the researcher or the investigator. If you are a researcher, if you are an investigator, if you are a teacher, you have been doing the problem. So this way you have to analyze it. You may analyze it in a much better way, but this is what is an idea I have given you. Difference between the sample mean and population mean is significant. We are 95% confident that the difference is significant. We are 95% confident. 5% chance of error is there. There is a chance of error of 5%. Let us find the level of significance at a 0.01. So if we are taking at 0.05, 95% we are confident that the sample mean and population mean difference is significant. If it is 0.01 level, exactly the same, only the critical value will be changed. There we had used critical value 1.96. Here we are using the critical value 2.58. So here see, again the calculated value is greater than the critical value. Our calculated value was 4.16. So 4.16 is greater than the critical value. Here also null hypothesis is rejected. Whether you calculate it, you do the calculation at 0.01 level or 0.05 level. At both level, you will find that the difference between the sample mean and the population mean is, there is a significant difference between the sample mean and the population means. Here we are 99% confident that there is a significant difference between the sample mean and population mean. Only 1% chance we are taking. Consider the question number 4. Consider the question number 4. My sincere request to all the learners, kindly record the answer. You should match your answer with the answer that we have been giving, so that the assignment what you are doing, you should not give any wrong answer in it. Yes, the quality of assignment may be little bit low, little bit high, little bit moderate. That part is acceptable. There is no issue because there is individual difference in preparing the report. But the mathematical calculation part should not be wrong. At least the mathematical calculation part should be correct. Interpretation may differ according to your and according to my interpretation. That is altogether a different thing. But the mathematical answer should be exactly same. Now see question number 4. Look the question for 5 seconds. Then we'll analyze the whole. On the question, you find out what are the given data. This is very important. If you segregate the given data, put it into your required format, then 50% of the question is solved. If you look into the whole paragraph, it is very difficult for the reader, the person who is looking into it. Okay? See, how do we analyze it? What is the population mean? 1000. What is the sample mean? 450. N is equal to 15. Standard deviation is 46.8. What would be our null hypothesis? There is no change in average daily profit. There is no change in average daily profit. So mu states that mu is equal to 1000. What is the alternate hypothesis? Mu is not equal to 1000. If the alternate hypothesis is mu is not equal to 1000, what type of test is that? Is it a one-tailed test or two-tailed test? Again, it is a two-tailed test. Taking two-tailed test, we have to find out the critical value. Listen, why I am finding out again and again, is it a one-tailed test or two-tailed test? For one-tailed test, the critical value is different. For two-tailed test, the critical value is different. If this concept is clear to you, there is absolutely no problem at any point of time. If it is a two-tailed test, at 0.01 level, critical value is 2.58. 0.05 level, critical value is 1.96. But if it is a one-tailed test, the critical value is different. That critical value, we have to get it from the table. For 99%, it is 2.33. If it is a one-tailed test, the critical value will be 2.33. If it is 0.5 level, the critical value is 1.645. That we are getting from the table. So you must have a very complete clarity that whether you are going to solve the problem with respect to two-tailed test or a one-tailed test. because the calculated value will be compared with the table value. When you are comparing the table value, you need to see whether it is a one-tailed test or two-tailed test. It is a left-tailed test or right-tailed test. That is very important. Otherwise, everything will be wrong. Now, see, what is the t-value? What is the t-value? Why you have taken t-value? Because number of days is 10, that is less than 30. So we have taken t-value. So sample mean minus population mean by standard error of mean. This is the same formula we have been applying. So what is the sample mean? 450. What is the population mean? 1000. Put all the values, you will get 45.49. So your t-value is 45.49. See, this is the calculated t-value. We have taken the given data, we have used the formula, putting it into the formula, we have analyzed it, we got the value is 45.97. Now we are going to compare this one with that of the table value. We are going to test whether the daily average profit has decreased. What is given? Whether the daily average profit has decreased. Look into the statement. Look into the statement. We are going to test whether the daily average profit has decreased. Is it a one-tailed test or two-tailed test? Of course, it is a one-tailed test. Yes,
One-tailed.
because it is. We are going to test whether the daily average is decreased or not. Means we are. It is a directional statement.
Correct.
So if it is a directional statement, so it is a one-tailed test. Is it a left-tailed test or right-tailed test? Of course, it is a left-tailed test.
Left.
Yes. It is a
Sir,
left-tailed.
one-tailed test is left.
Exactly. It is a one-tailed test, and we can say it is a left-tailed test because we are going to whether it is decreased or not. In case of decrease, if it would have given increased, then it is a right-tailed test. Then it is a right-tailed test. You need to have a complete clarity whether it is going less than mean, left-tailed test, more than the population mean, right-tailed test. Now, what would be the degree of freedom? The degree of freedom is 15 minus 1. Can you tell someone tell me why it is 15 minus 1? Can someone tell me why it is 15 minus 1?
Quantum test for this.
15 days of wage.
Number of sample is 15. 15. Number of
Profit
sample
in
is
15 days.
Yes, number of days is 15 days. Means n is 15 we have taken. If n is 15 we have taken, degree of freedom is n minus 1. Means
There is
14,
restriction for
14
one.
values may be of
There
any
is
value.
restriction for one.
The first 14 value may be of any value, but the 15th value must be a particular value in order to get the exact mean 450. Means we have only number of restriction is 1. Degree of freedom means how many number of restrictions are there in the hand of the researcher or in the hand of the investigator. In the hand of the researcher or investigator or the people involved in the research, they have in this question there is only one restriction. So the degree of freedom is n minus number of restrictions. Anyway, it is 15. Now refer to the table B. That is the second table given in the question. Degree of freedom is 14. Look into the left hand side column where 14 is there. It is 1, 2, 3, 4, 5, 6 up to 50, 100. You will get it. So where 14 is there and 0.01 level. 0.01 level because our level of significance is 0.01 level. Also see one-tailed test or two-tailed test. In the table, let us be very careful. 3 things you need to consider to get the table value. If somewhere at any point you are making a mistake, everything will be wrong. We are going to find the t distribution table. You need to refer to t distribution table. Z value table is different, t distribution table is different. The second table given in the resource page is the t distribution table. If you look into the t distribution table, in the left hand side column, you will get the degree of freedom. It is given, DF it is written, degree of freedom. At degree of freedom, you select the point 14 because our degree of freedom is 14 in this question. So degree of freedom is 14. And in the top column, you will get level of significance. Level of significance is 0.01. Again, under 0.01, we have a one-tailed test. If it is a one-tailed test, you have to go one step beyond previous, so that you will get there is a value for two-tailed test and there is a value for one-tailed test. For one-tailed test, the value here we are what we are getting. How much we are getting? We are getting it. The value is 2.62. So from the table, you will get the value 2.62. So our table value is 2.62. We read the value under 02, that is 5, because I told you it is a right tail test. It is a whether it is a left tail test or right tail test. So accordingly, you have to take a decision. So 45.49, this is the calculated value, which is much more greater than the table value. This value is, our calculated value is much more greater than the table value. So what you will do to the null hypothesis? Null hypothesis must be rejected. Null hypothesis must be rejected. So we can interpret that the average daily profit has decreased. But why? Because null hypothesis states that there is no difference in sample mean and the population mean. As the null hypothesis states that there is no difference, but as for the calculation, as for our analysis, we are finding that null hypothesis is rejected. We are not going to accept the null hypothesis. So we interpret in this way that the daily profit has decreased. So this is what is the question number 4. Coming to question number 5. This is the last question of this module. That is module 3, reference question 3. Take just 10 seconds and have a glance of the question. It would be easy for you. Kindly look into the question, please. Taking the question, just find out what are the given data. This is what is analysis. You are analyzing the question.
Dr. Das, Dr. Das, sorry for the intervention. On the screen, it is reflected that reflection questions module 2.
No, that is wrong. Module 3.
Yeah,
Module 3.
Yeah, we are seeing model 3, but it is
yes.
written on the screen that model 2.
It is a misprint. I am extremely sorry. Kindly take it as module 3. I request to all, kindly take it as module 3. Yes, sir. So let us see. Let us see. This is the given data. I have just presented you. I have made a small analysis of the question. Based on the analysis, I have presented. Population mean is given 100. Standard deviation is given 12. N value is given 50. Sample mean is 110. We are going to test whether the quantity of the waste has increased. The question is whether the quantity of the waste has increased. Is it a one-tail test or two-tail test?
One-tail.
One-tail test.
One-tail test, and it is a right-tail test. Right-tail test. If this one is clear, then it would be easy for you to find the table value from the table directly. This is the reason repeatedly I have been asking you, it is a one-tail test or two-tail test. While analyzing the question, this must be clear in your mind. You are working on a one-tail test or a two-tail test, because your critical value will be different accordingly. Accordingly, you are going to either right-tail test or left-tail test. Now,
Right-tail.
Yes, right-tail test. Agree. Come to the standard error of mean. You know how to calculate standard error of mean. You know how to calculate the standard error of mean. Standard deviation is given.
Standard deviation.
Yes, 1.69. Z value find out. D by ACM. D is
5.91.
Yes, 5.91. This much is clear. Now come to the next one. Come to the next one. Refer to the table value. Critical value of Z at 0.01 level of significance for one tail test is 2.81. This we will be getting from the table A, Z value. Table A, Z value. Now, what is the calculated value? 5.91. What is the table value? 2.181. So what we are getting? Our calculated value is much more than the table value. Here our calculated value is greater than that of the table value. If the calculated value is greater than the table value, null hypothesis is rejected. We can interpret that average quantity of waste has increased. So this is what is the interpretation we have made. I hope this aspect is clear to you.
Yes, sir.
This is all about your module 3. This is all about your module 3. You look into the module 4.
3.
Yes, module 3. Now we will see the module 4 questions. See, after completing module 1, module 2, module 3, I hope module 4 will be much easier for you, because we will not take much time on module 3. Rather, we will take on question answer session. So See, this is our module 4. If the questions are in your hand, kindly go through it. Our module is, sorry, it is module 3 is coming. Yes, module 4. Module 4. Fine. See, this is the first question of module 4. This is the first question of module 4. And just before going to module 4, I'll give you a 1 or 2 indication so that it will be easy for you. See, module 2 questions are different. Module 3 questions are different. Module 4 questions are different. Here in the module 4, till now we had only one sample mean. Taking the sample mean, we were making a comparison with the population mean, whether it is significant or not. For one tail test, for two tail test, we were doing it at a different level of significance, 0.5 level of significance, 0.1 level of significance. For one tail test and for two tail test, we were doing this. In module 4, we will make a comparison of sample mean with another sample mean. This is what is the difference between two sample mean. We are not making a comparison with the population mean. Now we are going to make a comparison of one sample mean with another sample mean. Means more than one samples are drawn from the same population. If more than one samples are drawn from the same population, whether there is a difference between the sample mean, if there is a difference, at what level the difference exists? Is it exists at 0.01 level? Is it exists at 0.05 level? What percentage of error we can tolerate? We can tolerate means as a researcher or as a teacher or as an investigator, you can bear. To a certain extent, we can bear the error. Whether you can bear the error, 1% error you can sustain or 5% error you can sustain. It depends upon the nature of the question. It depends upon the nature of the issue, nature of the problem at your in your hand. So these are the different aspects you will see.
Significance.
Yes. Now this is what, yes. Now look into the question 1. This is what is the question 1. We are going to find the solution. If you look into the question, I have analyzed the data given in the question in this way. Two schools are given. One is KVS, Kendriya Vidyalaya School. Another one is NVS, Navodaya Vidyalaya School. Maybe you can say school 1, school 2, doesn't matter. Maybe you can say schools of rural area and schools of urban area, doesn't matter. This is the two different schools. These are the two set of data given in the question. Fine. See, first of all, find out standard error of mean. Already in module 4, the theoretical aspect and the formula aspect we have already dealt. This is what is the formula for finding standard error of mean. Okay. If you use the formula, we will get standard error of mean is 1.25. ACM is coming 1.25. Now find out the Z. Again, the formula is same, D by ACD. D is the M1 minus M2. Mod M1 minus M2 means the sign is neglected. Whether it is positive sign or negative sign is neglected, always we take the positive sign. That is
Positive sign.
Yes, this is 1.92. I hope it is clear to you. There is no issue. This is M1 minus M2. M1 minus
Yes,
M2. 4. Now coming to the next one. What is the critical value? 0.05. Already known to you. Several questions we have already done. Now compare the calculated value with the critical value. 1.92 is less than the critical value. That is the table value 1.96. So null hypothesis is accepted. Okay. The observed difference 2.4 in favor of the students of KVS is not significant. As we are accepting the null hypothesis, means we are agreed with the null hypothesis. We are accepting the null hypothesis means what? We agreed with the statement that is formulated with the null hypothesis. So the observed difference is not significant at 0.5 level. Now, we are 95% confident in giving this statement. If we are 95% confident, means 5% error or chance of error is there. Now, if we accept the difference to be significant, what type of error will it be? Can anyone give the answer?
So alpha.
We have rejected null hypothesis. We have rejected null hypothesis. For the time being, just consider that suppose
Beta.
Type 1 error, sir.
Type error. Type.
Type 1 error. Type 1.
let us see.
Type 1 error.
Type 1 error.
Yes, okay. It is a type 1 error.
To accept the difference to be
Yes,
significant.
we accept the difference. In place of rejecting the hypothesis, if by mistake we are accepting the hypothesis, this is the mistake the researcher used to do. As an investigator, as a researcher, you should not make this mistake. If we are accepting it, then we are making type 1 error. That is alpha error we are making. Anyway, now refer to the table. We find 1.92 Z. Means the Z value is 1.92. What area percentage of area does it cover? It covers 94.52% of area. So the difference is may be seen in 5.48 only. Means 100 minus 9.54. We are 95% confident that there is. We are 95% confident. However, 5% error will be there. That is 100 minus 94.52. Means 5.4% of cases may go beyond it. In accepting the observed difference to be significant, we are 5.48% wrong. Now you have to decide whether can you, as a researcher, as a teacher, as an investigator, can you sustain 5% or 5.4? It means nearly 5% of error. This is up to the researcher. So the probability of type 1 error is 5.48. E is equal to 0.548. This is the probability of making a type 1 error if we are accepting it. This P is equal to 0.548. This now come to question number 2. Question number 2. Take a small analysis. Just 2-3 seconds you take. This is what is the question that is given. This is the question. Test whether the difference between the two mean weight is significant at 0.5 level and 0.01 level.
0.1 level.
Okay, both the level we'll see. We'll check both the level. See, can we say students of school 2 are provided with additional protein in midday meal as it has increased the average weight of the students? Let us see. This is the analysis I have made.
0.1.
Both the level will see.
0.1 level, sir.
We'll check both the level. Let's see. I don't know. You check the answer. Okay. First of all, find your ACD. How much is your ACD? You just compare. My ACD is coming 0.84. If you use the values are already given. All values are given in the table. Your ACD, standard error of difference between the school sample of school 1 and school 2. Standard error of mean difference. SEDM we can say. There is no issue. Standard error of difference is 0.84. Now what is the Z value? Yes, this is the Z value. 2.38. 2.38 is the Z value. See, what is the at 0.5 level? Critical value is 1.96. Is it fine? So 2.38, our calculated value is greater than the critical value. Can you tell me whether the mark difference is significant or not? Yes.
Significant difference is there, sir.
The mark difference is significant at 0.05 level. We have tested it at 0.05 level. Let us see 0.01 level. What is the critical value at 0.01? It is 2.58.
2.58.
The calculated value 2.38 is less than 2.58. Sorry, it is 2.58. It is 2.58. It is not 1.96. Kindly read it at 2.58. So the mark difference is not significant. 2.58. Yes. This is 2.58. It's a typing error. I am saying. Read it as 2.58. The cursor is marked here. 2.58. Okay. So here you see that the mark difference is not significant. See, the same question, the difference is significant at 0.5 level, but the difference is not significant at 0.01 level. Means the precision is more at 0.01 level. The accuracy is more at 0.01 level in comparison to 0.05 level. That's why at 0.5 level, the difference is found to be significant, whereas at 0.01 level, the difference is found to be not significant because the level of precision is high at 0.01 level. Now, coming to the second bit, whether the midday meal of school 2 contain additional protein as it increase the weight of the children. Is it a one-tail test or two-tail test?
A one-tail, right?
One tail and right tail test.
Whether it is increased Question is given whether it is increased. So it is a one-tailed test. And is it a right-tailed test or left-tailed test?
Right.
Both it is a right-tailed test.
Right.
Yes, exactly. Right-tailed test. Now we have to test whether the difference is significant or not. Now, one-tailed test, critical value is 2.33. Critical value at 0.01 or one-tailed test is 2.33. We are not using 2.58. Don't use 2.58. Those who will use 2.58, the answer will be wrong. Because 2.58 will hold good if it is a two-tailed test. As it is a one-tailed test, the critical value is 2.33. So we have to make the comparison with the critical value 2.33. So see, 2.38 is greater than 2.33. Null hypothesis rejected. Mark difference is significant at 0.01. Mark difference is significant at 0.1. So we can say that now midday meal provided at a school 2 contain additional protein with comparison to the midday meal provided by the school 1. As in school 2, the student's weight has been increased. So on the basis of this analysis, on the basis of this result, we can make a prediction, we can make inferences that the mark difference is significant at 0.1 level and the midday meal provided in the school must contain additional protein. So in saying we are 99% correct, only 1% we may wrong in giving this statement. This is due to why? The 1% error is due to what? Why there is a chance of error of 1%? Maybe sampling error, maybe fluctuation in the samples. Always we are not 100% right in selecting the sample. The sample may be there is sampling error or the fluctuation in sample. Because of the fluctuation in sampling, we may wrong in 1%. Anyway, come to the question number 3. This is your question number 3. Fine. I hope this is clear to you. Now I am going to question number 3.
Okay, sir.
Two groups are given, group 1 and group 2. All the data given. We need to test whether the mean difference in critical thinking at 0.5 level and 0.01 level. This is the critical thinking of 15 years age children of two different groups. We have taken critical value. Sorry, what is that? Critical thinking. You may take any other scientific ability. Creativity you can take, intelligence you can take, achievement test you can take. Any area of your interest you can take and you can find out. Now see. This is the analysis of question 3. Fine. Shall we move to the next one? See, immediately find out standard error of difference. Direct put the formula, you will get the answer. There is no issue. You will get 1.34. What is the difference? M1 minus M2. How much the difference is coming? 2.8. Okay. So what is the formula for the Z? D by ACD, already known to you. So if you substitute the value, you will get Z value is 2.09. What is the critical value? 1.96. Because it is a two-tailed test. It is a two-tailed test. So it is 1.96. So calculated value is 2.09. Critical value is 1.96. Compare it. Calculated value is greater than critical value. What do you say? Mark difference is significant or not significant?
Not
Significant.
Mark
Significant at 0.5 level.
Yes, exactly.
Significant.
Yes,
Significant.
95%
Sir,
confident.
significant.
Exactly, it is significant,
Sir,
and we are 95% confident that the mark difference in critical thinking between the two group of students are significant. Or other way we can say that we are taking a chance of only 5% error. We are 5%. There may be error in giving this statement. Now coming to the 0.01 level of significance. What is the critical value? 2.58. Here the critical value was 0.96. Now the critical value is 2.58. Make a comparison. Our calculated value is 2.09. So 2.09 is less than 2.58. So mark difference is not significant. Mark difference is not significant. So we are 99% confident that the mark difference in critical ability of the two groups of students are not significant. So the same difference. What is the difference? 2.8. The 2.8 difference is significant at 0.5 level of 0.5 level of significance, but it is not significant at 0.01 level of significance. So it depends upon the purpose for which you have prepared the test, the sensitivity of the test, the percentage of risks the researcher, investigator, or the management can take with respect to the purpose. If you are ready to take a risk of 5%, go ahead with 95% level of confidence. If you cannot sustain such a high percentage, high risk, 5% is a big amount, big risk. If you cannot sustain such a high, you cannot bear such a high amount of risk, you can increase the precision, you can increase the level of accuracy by taking the level of significance at 0.01, where the critical value is 2.58. Here you can see that you are only taking a risk of 1%. If there are certain questions where you don't want to take 1% even risk, if you again decrease it, you may go to 0.001%. You may go to 0.001. Even again, the what that is scientific laboratory experiment, what is going on, they used to take that level of significance with a minute level, they go. But so far as our purpose is concerned, in the field of education, maybe in school education, higher education, and any other field education, generally we take 0.5 and 0.1 level. So much more sensitive is 0.1 level of significance that is ready for us, and we can bear that error of 1%. But so far as scientific experiments are concerned, the experiments that are done in the laboratory experiments are concerned, you can increase the precision, you can increase the accuracy, taking 0.001, 0.001, 0.005 also. That is up to the nature of the question and the purpose for which the problem is being solved. Okay. Now coming to question number 4. This is our question number 4. Look into the question. Look into the question. As a teacher, as a researcher, we used to do this one. We should also to find the significance of various methods we have been implementing in our schools and colleges and universities. So a special intervention was given to 10 unemployed youth in English pronunciation skill. Pre-test was made before the intervention, post-test was made for the intervention. What type of method is this? Can anyone cite some example? Suppose you are doing this problem is you are encountering. What is the research method? Is it a historical method? Is it a survey method? Is it a descriptive method?
Experimental method, sir.
Experimental method, sir. It's experimental method.
Considering single group design. Considering single group design.
Yes, single group design experimental method. So pre-test is given, post-test scores are given. Step whether the mean score increased due to special intervention and test the level of significance at 0.01 level. This is the question. See,
This is the empirical method, sir. Empirical method.
Empirical method. I am a bit doubtful, but yes, empirical method. Empirically, you have to analyze it empirically. But what is the research method? Experimental.
It's an impact study of a training program. Hence, it's an experimental method.
I will not enter into it because that is again another one area, another one subject. So we will not be able to see it.
It is experimental method.
Yeah, as a pre-test and pre-test post-test as a experimental method.
Okay, fine. Now I am looking into it. What is the pre-test score? See, from the pre-test score you can find out the mean, because mean is not given in the question. This is a question where mean is not given, so we have to find out the mean. So sum of x1 is 107. If you add all these things, you will get 107. So the mean is 10.7. Is it okay? Coming to the next one. Deviation of each score from the mean. Small x1. Deviation of each score from the mean. This is the table. This is the deviation. I hope this is clear. Means score minus mean. Score minus mean for individual. We have found out this one. Now coming to this one. Square of the deviation of each score from the mean. Find out the square of the deviation. You will get this one. I hope you have done it in this way, or if you have done any other method, then compare the answer. See, what is the sum of square of the deviation? 156.1. So this is the information we are getting for the from the pre-test score. Okay, pre-test is over. Now coming to the post-test score. I will go to the post-test score. See, what is the post-test score? Sorry, this is the post-test score, not pre-test. It is post-test. Kindly read it as post-test. X2 I have written, but typing error is 3. So it is a post-test score. Okay. So what is the mean of the post-test score? 12.4. The mean of the post-test score 124.10 post-test score. Now what is the square deviation of each score from the mean? This is the table. You have to find out the deviation of each score from the mean. Okay. Fine. Now see what is the square of the deviation. Again you will get this. See, these are the things not given in the question. You have to do it by your own. As a researcher, you have to do. Maybe you can use any statistical package and do it, but a common clarity and understanding should be there with you. Even if you are using statistical package, you are using Excel, common understanding should be with you. Otherwise, you cannot make analysis and interpretation. Because we will not give you analysis and interpretation. You have to do analysis and interpretation. Critical thinking. The critical discussion is very important. And only if you have a understanding, you can do it. Otherwise, you cannot do it. Even I cannot do it. Now, see what is the square of the deviation. Sorry. Yes, this is the square of the deviation. Go to the next one. Now find out standard error of difference. This is the formula for standard error of difference. Two groups are given: control group and the experimental group. Okay.
Okay.
If you use the values we have already got it. You will get 1.63. What is the difference? 1.7. What is the t value? D by ACD. D by standard error of difference. Difference is M1 minus M2. Now, what is the t value? 1.04. I hope you have got it. I don't know what is your answer, but try to compare it. Your answer and with my answer. Okay. Refer to the table D. Degree of freedom 18. Degree of freedom 18. Now, can anyone tell me why the degree of freedom is 18? In each group, 10 students are there. In each group, 10 students are there. But we have taken...
Because 10
Sorry,
plus 10 is
here
20
N
and
minus
minus
1 plus 10
N
minus
N minus
10
1.
plus
N
10, 20
N1
minus
minus
2.
1 plus N2 minus
we
1.
have not made N minus 1.
Oh, N1 plus N2 minus 2.
Exactly.
It
N1
is
plus
N.
N2 minus 2. Because we have two groups.
N1 plus
We
N2
have two
minus 2.
groups. N1 plus N2 minus 2. Two groups are there. So we have taken one level of restriction. So two level of restriction, two restrictions are there. N1 plus N2 minus 2. Thank you very much. So the degree of freedom is 18. If you make degree of freedom is 10 minus 1 is 9, then everything will be wrong. Be careful in finding the degree of freedom. Critical value at 0.01 level is 2.86. This we will be getting from the table. The second table that is there. If you enter into the second table, degree of freedom, critical value 0.1, you will get 2.86. Now make a comparison. So what you will do? Null hypothesis is accepted. Because our calculated value is less than the critical value. Our calculated value is 1.04. Table value is 2.86. There is no significant difference between the pre-test score and post-test score. So we are 99% confident in saying that special intervention has no impact in bringing a significant difference between the performance of the youth in pronunciation skill. So giving special intervention is fine. Utilizing new methods, making experiment with the new method is fine. But always you need to find out, you make an experiment and find out whether the new method you are employing, whether the new strategy you are employing, whether the new teaching learning process, instructional process you have been adopting is giving any significant difference or not. Simply difference is not enough. Simply difference is not enough. Significant difference. Statistically, you have to make a proof that yes, it is significant with respect to at 0.01 level or 0.05 level. Now, come to the question number 5. This is the last question of our module 4. Look into the question. Look into the question. I know you have very much more doubts. Note down all the doubts. Raise the hand. Dr. Manas is with you. We'll take one by one all the queries and we'll try to resolve them. Fine. Now, see. This is what is our question. Should I proceed?
Okay, sir.
On the basis of the
Yes, sir. Right, sir.
The final
Yes,
score of
please.
two groups are this and this. See, here coefficient of correlation between the two group is given. It is 0.08. Look into the question, nature of the question, given data in the question. Based on the given data, you have to take a decision whether it is to find out the difference between the two mean for two independent mean or two correlated means. The module 4 dealt with two types of questions. One is for independent mean, another is for the correlated mean. So this question is related to finding the level of significance of two mean of two correlated mean. If it is two correlated mean, accordingly the formula is different, the process is bit different. Now look into it. Question itself it is given. Coefficient of correlation is 0.8. Test the level of significance at 0.05 level, whether the mean has increased due to spatial orientation. Whether the mean has increased, it is a one-tail test or two-tail test. Then it is a
One-tail.
One-tailed.
exactly
Right-tailed.
one-tail and right-tail.
Right.
Important for you to find out the table value from the p-value from the table. Okay, so very carefully one has to find out the p-value from the table. Look into the solution. Okay, this is what is your solution. This is the given data. I have not done anything. Simply I have extracted the data that is given in the question and I have presented it in a format which will be easy for the researcher or for the solving the problem. Okay, N1, N2 is given, M1, M2 is given, sigma 1, sigma 2 is given. Everything is given in the question. The moment you will be able to do this one, your 50% question is solved, I told you. Repeatedly I am saying it. Your 50% question solved. Automatically it will give you indication what to do next. Now come to the ACM, standard error of mean. Two groups are there. So find out the standard error of mean of group 1, sigma 1 by N1. You will get the answer is 1.91. Okay. Now go to the standard error of mean of group 2, that is 1.72. Is it fine? Now, what is this? Square of standard error of mean of group 1, square of standard error of mean of group 2, minus 2, coefficient of correlation, standard error of mean of group 1 into group 2. So this is the formula that is already given in your module. This is not anything new I have brought from somewhere else. It is given in the module. Very clearly it has given, and one problem has been solved in the module. See, what is the answer? Answer is 1.16. So standard error of difference between the two mean is coming 1.16. Okay. Now,
Okay, sir.
what is the difference? M1 minus M2 is the difference.
2.3.
Find out the D value, T value. D by ACD already known to us. So it comes around 1.3. It comes around 1.98. Those who have already done it, kindly match your answer. Maybe there is difference of 0.01 and 0.001 because somewhere you have rounded it, somewhere I may not have rounded it, somewhere I have rounded it, you may not have rounded it. If there is a difference of 0.01, doesn't matter. But marginal difference should not, major difference should not be there. 1.98. So we are testing whether the special intervention resulted increased in performance. Whether our intervention has any impact in increasing the performance of the student or not. This is what is our question. Is it a one-tail test or two-tail test? Already you have discussed it is a one-tail test.
One-tail test.
It is a left-tail test or right-tail test. Already you have told it is a right-tail test. Okay. Now what is the degree of freedom? N-1. That is 40 minus 1.
39.
39.
So refer to table B. That is the second table given in the resource space. You get use your own table. Any statistics the book you refer, you will get the table readily available. Even in the internet also, if you search it, you will get a number of tables. So any table you can use. There is nothing like that. You have to use this table only. So referring to the table B, see the degree of freedom 39. You need to see degree of freedom 39.1 level of significance. Is it okay? And a one-tail test. These three criteria you have to kept in mind while referring the table. What is your degree of freedom? what is your level of significance, whether it is one tail test value you are finding or two tail test value you are finding. As in this case, we have been dealing with one tail test, so our degree of freedom is our p value is 2.44. Is it okay? Now,
Okay, sir.
1.98 is smaller than 2.44, means our calculated value is less than table value. If the calculated value is less than table value, the difference is not significant.
Not significant.
significant.
Not significant. This is the indication. Null hypothesis is accepted. Means we retain the null hypothesis. Some of you have raised the question in the forum. There is nothing like accepted or rejected. I agree. You may interpret in that way. If you do not accept it, we can say that null hypothesis is retained. Let us retain the null hypothesis. We may say we will not retain the null hypothesis. In this case, we will say we will retain the null hypothesis. If we retain the null hypothesis itself says that there is no significant difference between these two groups. So we are 99% confident that special intervention has not made any significant impact in the performance of the students. So we are 99% correct in giving this statement or in interpreting it in this way. Only 1% error we have been taking. So this is what is the way you are required to analyze and interpret the questions. So I hope we have completed all the, what is that? Reflection questions. Reflection question 1 to reflection question 1 to 4. Now, based on that, it is very important that on your part to proceed to your assignment aspect. I don't know to what extent you have completed it. Hope you must have started. You must have already initiated a brainstorming of your own. What is my assignment? What am I supposed to do? What title should I give? In what way I will combine the 4 questions? Whether it is possible to combine the 4 questions or not, or I will take all the 4 questions in isolation with each other, individual some way, or you will combine 2 questions together and another 2 questions together. It's all depends upon you, because you are a researcher, you are an investigator, you are the preparing the report. All discretion is in your hand. So I expect that you should prepare it by your own. Absolutely, there is no restriction or rigidity in doing it. Prepare a title of your own, and in the introduction page, you need to cover all the aspects given. What is the background? What is the context? What is the objectives you have been taking? This is very important. Objective. Based on that one, accordingly, you have to make your body. That is the analysis and interpretation part. And finally, you have to make a discussion. That critical discussion is very important. Not more than 5, 6, 7, 8 sentences, 60 to 80 words. Make a small discussion, means critical analysis of the result what you got. Means when you are looking into the result, the values are in front of you. Don't write the same value in the discussion. The qualitative analysis of the value, what you got in the 4 questions, is to be represented in the form of a discussion. And that qualitative analysis, you may not write a 1 page, you may not write 2 pages. At least you try to write 3, 4, 5, 6 sentences. Something which are not visible to the naked eye, but it is coming out. That is what is the reflection of your result. The reflection of your result should be presented in the discussion part. Then finally give a conclusion. Conclusion, that is the conclusion of your own, as you have been giving and writing an essay and giving a conclusion. So 3 live sessions we had taken. Today is the last live session. I don't have time to give a present a model. Many of you have asking, kindly give a model of the assignment. Yes, I am ready to give you a model if the course management team will permit. You request to course management team on your behalf. I would request to Dr. Manas, if another one small session, maybe half an hour session or 1 hour session can be planned, then I can give a small presentation of what is the title, what is the introduction, what is the analysis and interpretation, and what is the result discussion part, and what is the conclusion part. And within 3 to 4 pages, how you will be able to complete it. I will make a presentation and we may go for analysis and question answer session, but I don't know whether it would permit by the course management team or not. The whole decision has to be taken by the course management team under the leadership of Dr. Manas Ranjan Panigrahi. So let's make a request if they permit. I cannot give anything to my own. So this is all about from my side. Now I am ready to take your questions. Over to Dr. Manas, please.
Thank you very much, Dr. Manoj Das, for your elaborate and patience-full presentation with each and every reflection questions. And I hope, in fact, I can have sure that maximum of participants are writing on chat box. I have seen, and they are very actively participating in this, as well as they are very much involved in this course and learning a lot with the different problems. I wish also these reflection questions will lead to them to when they will get a practical oriented scores or the data from their own profession, that will make them to appropriately, adequately choose a statistical technique to interpret, and on the basis of that interpretation they can able to analyze the data, and again they can draw at appropriate conclusion to their research and other aspects as well. With these words, we have before going to the question answer session, I can just tell you everyone, we have almost completed 1.5 hours of this presentation, and we may not take much questions because we need to, in time, we need to finish it. So another we have, I have just extended because it was only 1.5 hour session, but I extended for another 15 minutes for discussion. So let us have discussion. I can able to see here a few of participants, they raised their virtual hand, and I request Ipshita, can you mute yourself? I am muting you also. When you wants to speak, then only you can just raise your virtual hand. Then if I will ask you, then you can speak out of. So let me go one by one. First is Prashant Naik. Prashant, you can please very brief your question and pinpointed to your question.
Yes,
Prashant.
my question was, sir, can we take Z test or T test interchangeably? I was in the impression that T test is taken when the sample size is small and Z test for more than 30. But here in this session, I am seeing that T test and Z test are being taken interchangeably, even for sample number 40. 40 number of samples also, or more than 30, t-tests are being taken. So when we can take t-test and when we can take z-test?
Okay. So now, Dr. Das, can we take a few questions together? Then you can just compile after that, then another few questions.
Exactly.
Is it okay for you? Because maybe similar questions may raise. Okay. Prashant, please wait for your answer. I'm just making your hand lower. And now, Madam Prakash Suman. Prakash Suman, please ask your question. Prakash Suman. Ipsita, I request you, and I am also muting you, but you are unmuting yourself.
Okay, sir.
Yeah, Ipsita, please mute, otherwise it is disturbing to others also. Yeah, Prakash Suman, are you there? If you are not, then I am moving to the Santanu Patra.
Yes, sir. Sir, I have a gentle query. In module 4, question number 1, the question was test whether the difference in mean in favor of KVS is significant at 0.05 level. Whether when here the term in favor is mentioned, can we think it in a directional way? That is, alternative hypothesis, maybe mean of KVS is greater than mean of NVS. Then why it will not be one tail test? That's my question.
Okay. Yeah, again, this is regarding to the one tile, and there are two questions we received regarding to the t-test and z-test. Another one is the one tile is query. And next, Shashmita Majumdar, please.
Good evening, sir. Sir, I will request you kindly give another session for giving for that model of our assignment. Sir is ready, Dr. Das is ready to take another session. Please kindly consider that that will be actually beneficial for all the learners.
Thank you, Shashmita Majumdar. I received many requests in the chat box as well regarding to this. And definitely I will speak with very quickly. We will have a meeting with our team, and I will see on the basis of our team's recommendation. Definitely we will address your request. Thank you very much.
Sir. Thank you, Manu, sir.
Next, Preeti, please. Preeti, are you asking your question? Please, Preeti. Preeti, we are unable to hear you.
Yes, sir. Dr. Priya
please.
Kimnani. Dr. Priya Kimnani, sir, may I ask the question?
Please.
Yes, sir.
You log in on behalf of Preeti, or you are using Preeti's ID?
Sir, I'm using my ID. I think so. My ID is displayed.
This
Dr.
is
Priya Kimnani
Kumari.
here. Preet Kumari, sir. Yes, my ID, Dr. Priya Kimnani.
Kumari.
Yes, sir.
Okay.
Yes, sir. My question is that today we have solved the module 4, third question related to critical thinking, and in that we have calculated Z, and the same type of question was there in the module 4, example 2. In that we have calculated the T, as the N1 in that was 25 and N2 was 30, and here in the reflective question it is N1 is 25 and N2 is 20. So my question is that whether we consider the N individually to decide that the sample is small or large, because that is creating a confusion that whether we have to use the T or Z. Thank you, sir. That was my question. Individually, we have to consider the N, or we have to consider the N combined of both the groups to decide whether to move with a T test or a Z test. Thank you, sir.
So I will take one more question, then over to Dr. Das. One question is Omar.
Yeah, thank you, sir. Very much interesting, and I appreciate the way the instructors deliver the instructions to us. But I'm a bit confusion on the issue of finding the Z as a test, for example, the value. I've gone through different tables and get some difficulty, so that maybe if it's possible, maybe the instructor can maybe arrange so can at least get much more information how to calculate the Z value, because when you download the other tables and once you calculate you calculated the Z value from this table, it seems as different, though they saying that this is right tail test, for example, or left side over B is the other case one. That one. The right tail or left tail test, but it gets me some difficulty. I mean, to get exact value, because when I compare the one I get from the other table and the one in the instructor that is just maybe the answer I'm getting is quite different. So my side, I would like maybe more session. It could be possible just how to look the table in order to get T value and Z value. That is my question, sir. Thank you very much.
Thank you, Omar, for your query. Omar has some doubts on that table value and for Z score as well as T score, and probably Dr. Das will address to this. Okay, now over to Dr. Das for these questions. Then we will take one round of questions. Over to Dr. Das.
The first question and the third question, what I got on the T value and the Z value, both the questions are same, and the answer of both the questions are already given by the participants that are there in the first question itself. That is, can we take T value and Z value interchangeably? Absolutely. Even for large sample, if it is more than 30, in place of Z value, we can calculate the T value. We can take the T value, we can calculate, and we can proceed. We will get the same results. Even many of the experimental study, what we are doing, the significance difference between the two different methods of study, significance difference between two groups, when we are taking 30, 40, 50, 70, 80, we used to calculate the T value. So the T value remains same as that of the Z value so far as the number of sample is concerned. So both the values can be taken up interchangeably. Absolutely, there is no problem, no issue of any kind. But so far as the exactly small sample size is concerned, where the sample size typical experimental studies, there the sample size is maybe 5, maybe 10, maybe 15, maybe 20, maybe less than that. In those cases, particularly we use the T test only, and we refer the T table only, so that in order to get accurate value of the critical ratio from the T table, and as a result, there we don't go for making an interchange. But so far as the large sample is concerned, or the number of sample size is slightly greater than 30, 40, 50, 70, we can use T value, and we'll get the same value as that of the table value. There is no even 0.01% difference between these two. So generally it is said that even both can be taken up interchangeably. Absolutely, there is no problem or issue of any kind. But as a researcher, make it very clear that if it is a typical experimental research where level of accuracy is very, very important, even 0.001 will affect your result. In those cases, we should not use it interchangeably. We have to use the T test in order to get the accurate critical value from the T distribution table. I hope question number 1 and the question number 3 you got the answer. Now coming to question number 2, that is said, the reflection question number 2, that is comparison between the KVS and LVS, where it is given. Yes, the question was, test whether the difference in mean in favor of KVS is significant at 0.01 level. See, it is given whether the difference of mean in favor of KVS. In favor of KVS means the mean of KVS is coming 41.6. So 41.6 is greater than that of the 39.2. 41.6 is greater than that of the 39.2, that is NVS. So automatically in the question we are going to test whether the increase in mean of KVS is significant at that level, at 0.1 level, at 0.5 level. As it is given whether it is significant and indicated towards KVS only, not NVS. Other, in case it would have given that there is no test whether the difference is significant or not. Suppose it would have asked like this, test whether the difference is significant or not. In that case, you can say that it is a what? It is a two-tailed test. But in this question, it is given test whether the difference of the mean in favor of KVS, means it is a directional. The question itself is giving a direction towards the mean of KVS school. So Kendriya Vidyalaya school, Kendriya Vidyalaya mean. So it is a directional hypothesis. If it is a directional hypothesis, that is a one-tailed test. If it is a one tail test, as it is more than that, we call it as a right tail test. I hope this is clear to the person who has asked the question. And the second one, Dr. Manas, one of the participants told that the Z value, T value, everything is not bit clear and it needs some more clarification. I would request the learner kindly write the exact typical difference you have been facing. Even if you write in the email of my email or in the email of Dr. Manas, I will give you a clarification of it bit by bit to your question. It would be easy for you as well as for me what exactly you need, where you need some clarification, and what answer I will be able to give, so that I will be able to, my explanation will be helpful to you. So kindly write as many as queries, as many as doubts you have, give a mail to Dr. Manas or to me. So it will be easy for me and you to get a complete understanding of it. Dr. Manas, please. So this is what is the questions we got in the first round. So let us see in the second round what questions we are getting. Dr. Manas, over to Dr. Manas.
Thank you very much. Second round of questions we will take. And now I will take this opportunity to invite Lakshman Usri. Lakshman Usri.
Not audible. Sir, your mic is muted. Yes.
Yes, sorry. Good evening, sir. I was talking about the Z and T test only, but I've got the answer from you. But then I'll come with email. I'll send my email and my doubts through the email directly. Thank you.
Most welcome. Most welcome, sir.
Yeah.
Thank you. Next, we get the question from Navida Sher. Navida Sher. Dr. Navida. Dr. Navida. So next, can I ask Dr. Kavita Sarkar?
Hello, good evening, sir.
Kavita Sarkar. Yeah, please. Please. Kavita
Hello.
Sarkar, please.
Sir, I wanted to ask.
Yes.
Sir, in
Yes.
checking the progress, I found that marks are allotted for audio and for also for phone calls. So, sir, so I had a query that whom to make the phone calls and where can I find the audio?
No need. You just avoid these two options. Because in our course, these two provisions are not available. So no need to worry for that.
Okay, sir. And sir, and while answering, sir, the questions should be write the questions also. Well, should we write the questions also, sir?
Yeah.
Okay, we need to write the question also.
Yeah.
Okay. Thank you, sir. Thank you so much.
So now, Dr. Vivekananda Singh. Dr. Vivekananda.
Please unmute yourself, sir.
Dr. Vivekananda, please unmute yourself and ask your question.
Sir, good evening, sir.
Good evening.
Sir, good evening. Actually, I do feel proud to attend this program. So far as the discussion of Dr. M.K. Das is concerned, I am very much satisfied. So far as the data analysis is concerned and sample study, and so far as the research methodology or research technique is concerned, I got one technique is there, one method is there, that is one tail test. So my question is actually one-tail test is applicable in the number of investigations or not? So far as the sample study is concerned, data analysis is concerned, or research, that means technology is concerned, or research method is concerned. So one-tail method is the best method, as discussed by our honorable Dr. M.K. Das sir. So please answer me. Actually, one-tail method is applicable for number of cases or not?
Thank you, Dr. Singh. He will revert back to you definitely. Now, Dr. Mohammad Salam. He is from Bangladesh, please.
Good evening, sir. Thank you very much for giving me the opportunity. I am Dr. Salam from Bangladesh Open University. Thank you, Dr. M.K. Das sir, for his nice presentation and clearly explanation about the reflection questions. Actually, my question maybe goes to the moderator, Dr. Manas Panigrahi sir. That is actually, this is my first time to take this course, a mock course. So I want to know one thing, that is, suppose I am when I change my profile, suppose if I finish one video, my profile is changed immediately and I can observe it is already changed. So what about the moderator side or moderator team? Is it possible to change, check immediately, or they will check after end of the course? That means I want to know, is it monitoring regularly? Suppose when I change, I can see the change. And what about the team moderator side or the from the authority? So this is my question.
This is thank you, Dr. Salam. This is as you can observe your profile and your progress on course. Similarly, yes, everything is recorded on the system and backend. Whenever moderator and teacher wants to see, they can able to see. But definitely it is changed and recorded on the backend. And teachers are moderators and the mentors. They time to time visit and see the progress of the each and every individual learners. And according to them, when they felt that number of learners are lagging behind, so several times of announcement and constant emails are goes to each and every participants and the learners. So that is the alertness to the learners and providing adequate motivation to the learners to continue their course, which is they are lagging behind. Definitely, you are absolutely right. Thank you very much. I will take another 3 questions. Rita Devi, Sanjit Kumar, and Navida Sher. Now, first is Rita Devi, please.
Yeah, good evening to all, and I am very delighted with this MOOC sessions. This was also my first attempt. I have joined such a program, and it was very, very useful. And my again concern is regarding my progress. As I have watched all the videos, I have downloaded also the material. Some of the things I have shared also, but it is showing watching T3 and downloading 0. So I am also concerned whether it is being updated the way we are doing the things or not. And another thing is, sir, I missed a few minutes of the initial session of today's presentation. So will it be available so that I could see the whole, as I could not attend the initial part? I missed today's session. It was very important, but really missed due to device problem. I have written also. Thank you so much.
Thank you, Rita. Thank you, Rita Devi. Thank you very much. After completion of this session, and the video will be shared with you in your email. You will definitely get an email, and where you will find the this video link, YouTube video link. Using that YouTube video link, you can able to watch again this live session, recordings of this live session. So
thank you, sir.
About regarding to your progress, you please see again your profile. Something is you are doing mistake in your process handling in the platform, which is unable to catch the record. So you please watch again the videos. If it is showing 100%, either you are unable to see that profile, or you can take any help of the somebody who is a little bit good in computers, so that they can able to help you in this regard as well. So moving to that Sanjit Das. Sanjit Das, please.
Yes, sir, very good evening, Manav sir and Manoj sir. Sir, just wanted to know, like in this assignment, we are supposed to do these 4 questions. So we have selected the 4 questions and we have done. So whether in the assignment we have to mention that this question is from 1, 2, 3, 4 like that, or we have to imbibe those things, and can we change the name? Suppose in the question is written they have studied on class 10 exam. Can we change it to something else so that we can fit to the context? That's the question, sir.
Okay, thank you, Sanjit. And we will revert back to Dr. Das. But before that, Dr. Navida Ser. Navida Ser, if you are there, you can ask a question, because you raised your virtual hand.
Good evening, sir.
Yeah, please, Navida.
Sir, first of all, I would like to appreciate your, like you gave us such informative sessions in this particular course. It was very informative, and we got such information from this particular course that will help us throughout our life when we are related to statistical analysis and other things related to research. And my question, I got the answer to my questions. Whatever question there was in my mind, I got answer to all the questions. But there is a question related to one-tailed, two-tailed, and whether there is a right-tailed, left-tailed, or the, I can say two-tailed. How to determine whether the hypothesis test is left-tailed or right-tailed, or how we can determine that it is the two-tailed test. This is my question.
Thank you very much, Navida. Now, without wasting time, because we have only 3 minutes to close this session, so I can allow 2 minutes to Dr. Das to reflect these questions. Then 1 minute I will conclude. Then we will say bye-bye to each other and move towards the platform again. So over to Dr. Das.
The last question I am taking first. How to determine whether it is a one-tailed test or two-tailed test. See, you are framing the null hypothesis and alternate hypothesis. The moment you will set your alternate hypothesis, from reading the alternate hypothesis, you can decide whether the test is a one-tailed test or two-tailed test. Suppose your population mean is 150, sample mean is 120. So if alternate hypothesis says that sample mean is not equal to population mean, there is no significant difference between the sample mean and population mean. There is no significant difference between sample mean and population mean. It is a two-tailed test. There is no significant difference between sample mean and population mean. It is a two-tailed test. If alternate hypothesis will say that sample mean is greater than the population mean, means it is a one-tailed test. Or sample mean is less than population mean, it is a one-tailed test. So depending upon the statement you have prepared for alternate hypothesis, you can say that whether it is a one-tailed test or two-tailed test. If it does not give any direction, it is a two-tailed test. If it gives a direction, either increase or decrease, less than or more than, it is a two-tailed. It is a one-tailed test. If increased, right-tailed test. If decreased, left-tailed test. So this is what is the concept. For more, you please write an email to me. I will write you clearly explain in the mail. Now, one of the question was that whether the t-test can be used in many of the research study, what we have been doing in many of the field. Yes, it is being utilized by the researcher and investigators and the people, those who are involved in research, impact and feedback studies. Not only in the field of education, even in the field of medical, even in the field of agriculture, even in the field of any other area, wherever the research is going on, the people are using the t-test. even Z test, they are using depending upon the nature of the study, depending upon the nature of the problem. It is not that only the people associated with education we have been utilizing. That can be utilized effectively, efficiently for the purpose of the study. Now, another thing, can we change the order of the question in the assignment? Absolutely, you can change the order of the question 1, 3, 4, 5. There is nothing like that. You need not mention from which module, from which question you have given it. It should be known to you as a report writer and as an investigator, as a researcher. So it is your discretion which order you maintain, whether you want to give the complete clarity within that limited words, it is fine. If you cannot give, if you want to make it precise, that is also fine. Rest of the things, in case we will get an opportunity, I will show you how to prepare. Let's wait and watch what is happening. Accordingly, all your doubts will be clear. Thank you very much, Dr. Manas, and all the learners for sparing your time and patiently hearing to me and my team. And we expect that you all should clear all the requirement, basic minimum requirement for the acquisition of a certificate of participation as well as certificate of completion. It is not that difficult. It is very easy. I assure you that. Please spare some time, 1 or 2 hours only. You will complete your assignment. Wish you all the best. Are the best to complete both the certificates and acquire both the certificates. Over to Dr. Manas, please.
Thank you, Dr. Das. There are some queries in YouTube also, but I was looking to get question from YouTube, but I'm not getting so far. Okay, thank you very much. Thank you all the participants who joined or who are not yet joined this session.
Excuse me,
who are
sir.
not yet joined to this.
Namaste, sir. Actually, proud to attend this program, sir. Namaste.
Sir,
Namaste and good everyone, sir.
Question, sir. Sir, I have a doubt, sir. I want to ask.
Devirani, please ask your question, please.
Thank you, sir. Sir, first of all, yes, sir. Sir, am I audible, sir?
Yes, you're audible.
Absolutely,
sir,
please.
Yes, sir. Sir, first of all, I am so very grateful to you all because I have been really developing myself in statistical analysis from this course platform. Sir, but in module 4, I'm confusing a little bit. And in module 4, 2 formula for test of significance are given. These are, sir, formula number 1, the obtained value is greater than equal to critical value, then the difference between 2 means is significant in a particular level of significance. In formula number 2, if the obtained value is less than equal to critical value, then the difference is not significant. Sir, actually, I'm confusing in this second formula. Is it right, sir? If obtained value is less than equal to critical value, then the difference is not significant.
Exactly. Yes, absolutely correct.
Sir, less than equal to also, or
No,
only
yes,
less than?
Less than equal
Sir?
to.
Equal to, sir. Sir, just,
Less than equal.
sir, I want to give an example, sir, please.
See, what level of accuracy you are expecting, it depends upon the nature of the question and the nature of the purpose of the research. If you are so particular, if the researcher is so particular, pertinent, doesn't want to take any risks of any kind, then he may say, he or she may avoid the equal to, only take less than. Suppose in the sensitivity of the study is not that much of a, it is not that much sensitive, then you can take less than equal to. So it is up to the researcher. But that is a line of a.
Yes. Sir, I am citing an example, sir, please. Suppose to test the significance at 0.01 level of significance, suppose the obtained value is 2.58, sir. And the critical value at 0.01 level of significance is also 2.58. So here obtained value is equal to critical value.
Yeah.
As the 2 formula given in module 4, as per the first formula, the obtained value is greater than equal to critical value. It fulfills this condition also, sir? equal to 2.58 obtained value, also 2.58 critical value. So it fulfills this formula. That's why it is the difference is significant.
So, as an investigator, if you ask me, if I have been doing the research, I will get a situation like this. My obtained value is 2.58. My table value is 2.58. 2.58 is equal to 2.58. I will interpret it in this way that the difference is significant at 0.01 level.
Sir, as per second formula, sir. Sir, as per second formula, obtained value is less than equal to critical value. Sir,
Bevirani, thank you very much for your question. Dr. Das, thank you very much. I am forced to end the session here because this is all about the technology. My technology is not allowing me to go permission. And Sunilji, please be on the forum. Dr. Das will be immediately moved to the discussion forum and he will answer each and every question, including myself also. We will be on the discussion forum. Actually, discussion forum is only for this purpose. So this is just live sessions. Why we are doing just exceptional questions can taken and discuss. So thank you very much for your presence and thanks a lot. I wish all of you will be in the discussion forum right now, right self. Definitely you will get Dr. Das will attend your questions and our mentors and facilitators will definitely attend your questions. Thanks a lot and good night. Stay safe. Enjoy your time. Thank you very much. I am ending here, Dr. Das.
Thank you. I am available for 2 hours. Most welcome.
Thank you. Bye bye. Good night. And good day.
Thank you, sir.
Good day. Good morning.
Thank you, everybody.
Bye bye.
Thank you, sir.